This is a CCEA A2 Pure paper. This one's from June 2023, and we're taking a look here at question number 3. So there's two different parts to this. The first part is going to be the trapezium rule, and the next part then a bit of rotations for integration. So question 3, the graph shows the function y was x squared upon the square root of x cubed plus 1. Here's my graph here. The region R is the area enclosed between the curve and that, the x-axis, and the line x equals 1. That's the way I have it run up here. Find the approximation for the shaded area R using the trapezium rule with 4 strips. So 4 strips is going to be our 5 ordinates. So you can see the 4 strips here. We're going to have this one, this one, this one, and this one. And so my ordinates then are going to be 0, a quarter, a half, 3/4, and 1. So let's get our table drawn up then for this. So my values of x, as I say, are 0, 0.25, 0.5, 0.75, and then 1. Just to keep things vaguely neat here. And so then my y coordinates then for each of those, if I put 0 into this here, I'm going to get 0. If I put 0.25, again I'm substituting into this, you can take my word for it, you're going to get 0.0629986. If you substitute in 0.5 into this, you get 0.265. 165. Substitute 0.75 in, 0.670739, and you substitute 1 in, we get 1.414214. Now people do this different methods. The method I do is I normally work out most of the bit of the trapezium rule here. I'm going to try and find the trapezium rule here for you. So let's take a look. So here it is in the formula booklet. So we have this here. So it's half upon h. So h then is going to be our width, which was going to be a quarter. So it's a quarter then divided by 2. And then upon y0 plus yn. So that's the first and the last one. And then 2 upon each of these. So the way I do this is I'm going to then the trapezium rule here, and that'll give me the whole kind of big bracket thing worked out. So I want one of those, and I want one of those, and I want 2 then of all the bits and pieces then in between. So I'm going to double this one, and this one, and again that'll appear then in just a wee second. So just to clarify that again, these are all my y values, and the way the trapezium rule works, we need one of these, and then 2 of each of these. So I've times this by 2, this by 2, this by 2, and then I'm just going to total that up. So whenever I total that up, I get 3.4199. So therefore my area of R is going to be 0.25 over 2, hopefully we're happy enough, and 0.25 as a gap, all upon then 3.4119, and if I stick that in the calculator, I get 0.426 square units. On then to part 2. The region R in figure 2 forms a solid when rotated through 2 pi radians about the x-axis. Find the volume of this solid. So we're going to rotate this round. So remember our formula. So it's going to be y squared. It's the integral of y squared then upon pi. So we'll see my y is equal to x squared upon this square root of x cubed plus 1. That means the y squared, squaring this gives me x to the 4, and squaring this of course gives me x cubed plus 1. We're going to have to integrate this, so to multiply that out then it's going to give me x to the power of 7 plus x to the power of 4. So remember my volume formula is pi upon the integral. Remember it's between 1 and 0. Let's go back and show you why that is. There's my 1. There's my 0. And then it's x to the power of 7 plus x to the power of 4 dx, because that then is my my y squared. So it's going to be pi upon x to the 8 over 8 plus x to the 5 over 5, and that's between 1 and 0. Not too much working out there really, so we effectively are going to have 1/8 plus 1/5, take away then the 0, and the 8 plus a 5th, you need to go into 40ths, so you're kind of going to get 5 40ths here and 8 40ths here, so it's going to be, my volume then is 13 pi over 40 cubic units.